Okay, so we were actually left with some of the topics of the divide and conquer approach. We have finished the dynamic programming and few mini little topics of divide and conquer are still left behind. So one of them is the matrix multiplication, but using the Strassman's technique. So traditionally, if we see how we perform the matrix multiplication, if we have the two matrices A and B, the elements whose elements are given with a size of 2 cross 2. Means this contains two number of rows, two number of columns, and similarly this next matrix also contains two rows and two columns. And we are interested in finding a third matrix C by finding the matrix multiplication of these two. And in the linear algebra, how we do it? We simply take the first row of matrix A, multiply it with the first column of matrix B, and that becomes the C1 and 1th element of our third matrix C. So our C11 will be equal to A11 into B11 plus A12 into B21. The second element of our matrix C, that C12, will be equal to again the same row but with next column. So A11 B12 plus A12 B22. So the thing is that if we are having a matrix of size 2 cross 2, this is 2 cross 2 matrix, this is 2 cross 2. So we use these sort of formulae to calculate the product of the two matrices. And for finding the total number of multiplications, if we count here, we are multiplying A11 with B11. This is one multiplication, second multiplication, third, fourth, fifth, sixth, seventh, eighth. So in a 2 cross 2 matrix, we need 8 total number of multiplications. And remember that this is not an ordinary multiplication, that we are multiplying a 2 with 3, it becomes a 6. This is matrix multiplication. And matrix multiplication is a very time consuming process. And the total amount of time it takes to multiply two matrices of the sizes given, that determines the complexity of that algorithm. Okay, like in this case, the complexity is order of n cube, which means the total number of multiplications we have to actually make in order to find this product A cross B. Since n is the size which is 2 here, so 2 power 3 will be equal to 8, which is again equal to the number of multiplications total which we need to perform this matrix multiplication. So we take 2 cross 2 matrix as a small problem in divide and conquer approach. Since when we divide a large problem into small problems, we should be also defining what a small problem is. So in matrix multiplication, we take any matrix of size 2 cross 2 or lower than that as a small problem. So any matrix which is greater than 2 will be taken as a large matrix, means whose size is greater than this 2. There are more than 2 number of rows or columns. That will be a big problem. And if you see, in order to find the matrix multiplication using an iterative process, using the looping system without using the recursive call, we need 3 loops. The first one will be to iterate around the rows, then this one will be to iterate around the columns, then we make a third matrix, initialize it, and put the values inside this third matrices. by using this equation. This is nothing new. If you go and visualize the control of this pseudocode by taking I is equal to 0, then this is a sub loop or a nested loop, j is equal to 0. Then this case again a sub loop. You will find we will trace all the elements, find the multiply the row with the column at each iteration. So the point here is actually to again say that since we need 3 loops in order to find the matrix multiplication using this iterative approach, so its complexity will be also order of NQ, because when we know the number of loops, particularly the nested ones, we take just that number of loops. It's 3 loops, so it will be n cube. Simple. Now, this was the case when we were discussing about the two matrices whose size was either equal to 2 or less than 2. But what happens when the size of the matrix gets greater than 2? The example is in front of you. This is a size of 4 number of rows, 4 number of columns. So 4 into 4. This is also a size of 4 into 4. So now this is a big problem for us. So we will use the divide and conquer approach. And once we use DNC approach, which means internally we are making the recursive calls. Each time we divide the large problem into small ones and we make a recursive call. If we see to this matrix A, we are dividing it like this into 4 partitions. This becomes one, this becomes another, this is another, this is another. So we actually divide it into 4 parts. And we rename this part as capital A11, A12, A21, A22. Similarly, we do it for B11, B12. So we actually divide it into 2 parts. Initially, its size was n. Now we are dividing it by 2. So initially, its size was 4. We are dividing the row by 2 and column by 2. So we will get 1, 2, 3, 4, 5, 6, 7, 8. We will get 8 matrices but of size 2 cross 2. Is it critical? Is it complex to understand? We are dividing by 2, so we will get here this A11 will be itself a matrix of size this 2 cross 2. This A12 will be also a matrix of size 2 cross 2 because it contains 2 rows, 2 columns. All those new matrices contain 2 rows and 2 columns. So because 2 rows and 2 columns is a small problem for us. So that's why we are dividing this large problem into this small problem. यहाँ तक क्लियर है ना? बट जो ये कैपिटल A11 है, it is actually equal to this small A11, A12, A21, A22. इसमें यही एलिमेंट्स है, यही 4. तो A11 जो है या A12 जो है, कैपिटल वालों की बात कर रहा हूं मैं, they are indirectly also the matrices. They become sub matrices of the original matrix A. These become sub matrices of the original matrix B, but of size 2 cross 2, 2 cross 2, 2 cross 2. है ना? So for 2 cross 2, I know that when a matrix is of size 2 number of rows, 2 number of columns, find their product, this is the formula. So when I divided this matrix, this is 2 cross 2, I will apply that formula. This is 2 cross 2, I will apply that formula for all those matrices as they become 2 cross 2, which means it is now under my control. It's small and I can apply those 4 formulas for small matrix multiplication. Now I am here. So I am now actually making a divide and conquer approach or a pseudo code to solve this problem. So what will I do is that I will make an algorithm matrix multiplication and I am passing 2 matrices to it, A and B. with their sizes n, and here n is equal to 4. Simple. So then I will check a condition. If the size, if n is less than or equal to 2, अगर साइज 2 से या 2 के बराबर हो, इसका मतलब है ये स्मॉल प्रॉब्लम है, और स्मॉल प्रॉब्लम के लिए मैंने फॉर्मूला ऑलरेडी पता है. दिस इज द फॉर्मूला बिकॉज साइज इज 2 क्रॉस 2 और लेसर देन दैट. बट चूंकि यहाँ पे जो साइज है वो n है, वो 4 के बराबर है, तो इसका मतलब है ये कंडीशन ट्रू नहीं है. दैट मीन्स द एल्स पार्ट विल बी एग्जीक्यूटेड. और else part के केस में what will happen is that I will firstly divide the size by 2. So I was having n is equal to 4, which means it will become 4 by 2, that's equal to 2. So every matrix will be now divided by 2, and this will become a size of 2 cross 2, 2 cross 2, 2 cross 2, 2 cross 2, 2 cross 2. So how many sub matrices of size 2 cross 2 I will be getting? 8. Because this A11 is itself a submatrix of size 2 into 2. This is also 2 into 2. Everyone is of size 2 cross 2, and total is 8. So I can make then a recursive call, because this is a divide and conquer. Recursive call of what? The original algorithm matrix multiplication, same thing. And I am passing it the new parameters A11 comma B11 comma n by 2, because I am decreasing the size by dividing by 2. A11 B11, what does that mean? A11 has to be multiplied by this one B11 plus A12 has to be multiplied by B21. A12 B21 and its size is also by 2 divided by 2, and we take their addition because we multiply the column, the row to the column, and take their multiplication. This will be the first call. The second will be, again I am passing the matrix multiplication with parameters or with new matrices. What are those? A11 B12, which means A11 and B12. This row will remain same, column will change. First step we were here, second step we will take this one. So A11 will get multiplied to B12, and their sizes are now n by 2 plus A11 A11 B12 A12 B22, A12 and B22. This will get multiplied with this. Means first with this and this A12 with B22. And similarly, we will take then the second row of this. That's A21 into B11 plus A22 into B22. B21, yes, and A21 into B12 plus A22 into B22. By passing the size also as an argument which is present in the original matrix multiplication algorithm, and since these capital A, B, these are itself the matrices of size 2 cross 2. And if you look closely to this pseudo code of divide and conquer, what we found is that we had to make 8 recursive calls to this matrix multiplication algorithm. 1, 2, 3, 4, 5, 6, 7, 8. 8 times we have to call this algorithm, okay? So, if I had to make a recurrence relation for this matrix multiplication algorithm using divide and conquer, I will make it here that T of n is equal to some constant B1, 2, whatever. If n is either equal to 2 या 2 के बराबर है या 2 से कम है, तब ये कोई भी कांस्टेंट है ना. अब अगर ये 2 से ज्यादा हो गया, 2 से ज्यादा अगर ये हो गया, तो मैं दिस मैट्रिक्स मल्टीप्लिकेशन वाला एल्गोरिथम t of n by 2, आई एम पासिंग इट द आर्गुमेंट n by 2, है ना, और इसको कितनी बार मैं कॉल करता हूँ, 8 बार. So 8 t of n by 2, this will be addition of all those, plus this n square is the addition, the amount it takes to add those matrixic values, then this addition. क्योंकि ये मैट्रिक्स का एडिशन है इसलिए हम n स्क्वायर भी लेते हैं. इन केस इवन इफ यू इग्नोर इट, इट वोंट मैटर बिकॉज दिस फैक्टर इज एक्चुअली प्लेइंग द पार्ट. नाउ वी आर हैविंग दिस रेकरेंस फॉर दिस सीडो कोड. अब इसमें a 8 के बराबर है, b 2 के बराबर है, और f ऑफ n इज दिस n स्क्वायर फंक्शन. log a to the base b मैं फाइंड करूंगा a to the base 2 which will be equal to 3, है ना, और k की वैल्यू होगी इस n का पावर क्या है, जो फंक्शन है जिस f ऑफ n उसका पावर क्या है, दैट्स 2. सो log a to the base b जो 3 के बराबर मुझे निकला, दैट इज ग्रेटर देन दिस 2, है ना, 3 इज ग्रेटर देन दिस k. सो दिस इज द मास्टर्स थ्योरम मेथड. व्हेन log of a to the base b is greater than k, it comes under case 1. एंड केस 1 मुझे बोलता है कि जो भी आपका log a to the base b वैल्यू निकलेगा, n को वो पावर कर दो. चूंकि यहाँ पे मुझे वो 3 निकला तो n को मैं वो 3 पावर करूंगा. दैट विल बी द कॉम्प्लेक्सिटी ऑफ दिस रेकरेंस रिलेशन, है ना. तो इसका मतलब है आई ट्राई टू इम्प्लीमेंट द मैट्रिक्स मल्टीप्लीकेशन using iterative way, using an iterative method, I am getting time complexity of n cube. If I try to implement that using the divide and conquer method, the time complexity is again order of n cube. So is there a way by which we can decrease this order time complexity of matrix multiplication, because order of n cube or n cube is too much, है ना. ये पॉलिनोमियल टाइम ऑर्डर क्या है, क्या इसको मैं किसी तरीके से रिड्यूस कर सकता हूं. और रिड्यूस करने के लिए इस बंदे ने ये जो नाम आपको यहाँ पे दिख रहा है, इसने एक अपना मैट्रिक्स मल्टीप्लिकेशन एल्गोरिथम दिया. दिस मैन हैज गिवन एन एनहांसमेंट टेक्निक टू दिस मैट्रिक्स मल्टीप्लिकेशन by decreasing the time complexity of the algorithm a little bit lesser than this order of n cube. Not too much, but a little bit he has done. And that improvement is known as Strassman's matrix multiplication. The algorithm is quite beautiful, which he has proposed. No doubt its name is not so beautiful. So what he said is that चूंकि हिंदी और इंग्लिश के चक्कर में ना, चूंकि in the matrix multiplication, as I said, it is the multiplication operator which is actually determining the total time the algorithm will take. Since here we were making 1, 2, 3, 4, 5, 6, 7, 8 number of multiplications. So he said that if we decrease the number of multiplications by a certain amount, if we decrease the multiplications by a little bit certain amount, that will decrease the total complexity of that algorithm. And what he did is that he took the example of this same two matrices A11, B12, B11, B12, what is this thing? And he said that instead of 8 multiplications, we can compute the value, actual value, what we have to compute is the matrix C. और उस मैट्रिक्स C के हमने इन एलिमेंट को फाइंड करना है, C11, C12, C21, यही तो हम प्रोडक्ट में करते हैं. He said that instead of taking those elements A11, A22, let's take those new elements which he described, P, Q, R, S, T, U, V. These new elements were introduced by Strassman. And he used the formula P, because this equal to this thing as similarly v. And whatever the formula he has given, if you see, we need one multiplication here to multiply this with that. 1 here, 2, 3, 4, 5, 6, and 7. And he gets the result C11, C12, C21, C22 using the addition of those. So point is that instead of taking those 8 multiplications to get the value of the third matrix C, he took those variables, reformulated the formula in a way by taking only 7 multiplication, और third matrix भी उसको वही मिली जो उस तरीके से मिलती है. If we make a recurrence of the Strassman's matrix, it will be same for case n is equal to 2 or less than 2, but for greater than 2 we need 7 tn by 2, means we need only 7 multiplication in place of 8 जो हमने पिछली बार चाहिए थी. अब इस रिकरेंस को सॉल्व करने के लिए मास्टर्स मेथड हम फिर से लेंगे. a 7 के बराबर अब है, b 2 के बराबर है, फंक्शन जो है n स्क्वायर वो उसी के बराबर है. log a to the base b will be equal to log 7 to the base 2 and that's equal to 2.81 जब हम इसको फाइंड करते हैं. और k फिर से स्क्वायर इस 2 के बराबर है. So log a to the base b is greater than k, है ना. 2.81 is greater than 2. So time complexity at this time will be order of n to the power 2.81 की n को जो ये पावर है log a to the base b जो निकला उसको पावर कर दो. So in the previous case we were getting the order equal to order of n cube. So the Strassman made an enhancement to matrix multiplication by getting the same results by decreasing the time a little bit, maybe by from 3, that's from cube to 2.81, and this is most often number of times being asked in the GATE exam in this thing, because quite often we forget those values. So it is not the end of the world, because somebody among you may also try to find some another way of matrix multiplication whose cost will be even lesser than this one, है ना. एंड उसको हम कहेंगे कोई राहुल एल्गोरिदम और जो भी आपका नाम होगा, चरमीशाज एल्गोरिदम, है ना. किसी का भी. So the field is open for all the people, है ना. At present we are at this stage. All right. So the next one in this divide and conquer is exponentiation. Okay. It's not such a complex to understand, but being part of the syllabus, let's throw some light on it also. Exponentiation का मतलब ही क्या होता है? Something raised to the power something. That's it. A to the power 27. So what does that mean is that if we have to find a to the power 27, that means we have to do multiplication of a with itself 27 number of times. A into A into A into keep on doing it until it reaches to 27, है ना. So 27 number of multiplication. Is there a way we can decrease the multiplication? Because as I said, multiplication is a very time consuming process. So is there a way? Let's find it. So we can write this a to the power 27 as equal to a into a power 26. Because bases will be same, they will get add up, it will be again a to the power 27. And I can go next step down. This a is a, no change. This star is star, no change. Inside it's a to the power 26. I can write it a to the power 13 and externally I will keep 2. So that will again 2 will get multiplied by 13, it will be 26. है ना? A pure mathematics actually comes into play here. So I will go one step down, a will come here. This inside those brackets, I can write this a power 13 equal to a into a power 12. Huh? And outside is this square, to whole of this square. All right. So again, I can divide it into small chunks because actually I'm using divided conquer here. So let me divide it again. This a is again here, then bracket, this a is here, okay, then star is here, then inside. A power 12 can be written as a power 6 outside 2, then whole outside this 2, है ना? फिर से और एक स्टेप में नीचे जाऊंगा. अब a power 6 जो है, I can write it a power 3 outside 2, then this 2 is here, then this 2 is here. Again, I will go one more down step, a, and inside this bracket it is a power 3, that I can write as a into a square. And if you count the total number of multiplication needed now, a को पहले a के साथ चूंकि स्क्वायर फाइंड करने के लिए मीन्स 1, उसको इस a के साथ हो गया 2, फिर उसका स्क्वायर हो गया 3, फिर उसका स्क्वायर हो गया 4, उसको a के साथ हो गया 5, उसका स्क्वायर 6, उसको a के साथ 7. So I will get result only in 7 multiplications. That is the beauty of D and C. Okay. So that means if I try to find out a recurrence relation for such equation, or I am having an exponentiation term a power n, which is equal to a itself if n is equal to 1. अगर n 1 के बराबर है means this is a, it will be equal to a. There is no power, there is no multiplication. The second condition is that अगर n even है, if n is even, like here 8 to the power 26, it became even, n is equal to even here. So at that very time a of n is equal to a power n by 2 whole square, which means a power 26 divided by 2, which will be 13 और उसका स्क्वायर. अगर अब n ऑड है, ऑड का मतलब a पावर 27 जो कि पहला ही इंस्टेंस है. If n is equal to odd, which is equal to 27, then a is equal to a power a n minus 1. A power 27 minus 1 will be 26 into a. 26 into a if n is odd. So to make a pseudocode, I will first of all use the exponentiation divide and conquer algorithm by passing the parameters a and its power n. Then if n is equal to 1, the same thing in terms of pseudocode we are writing it now. If n is equal to 1, then return a. अगर नहीं तो if n is even, then return, make a recursive call to exponentiation divide and conquer algorithm by passing the parameters a, n by 2, उसका स्क्वायर जो यहाँ पे हमने ले लिया. अब अगर वो चीज भी नहीं है, अगर ऑड है, तो रिटर्न क्या कर दीजिए मुझे a क्रॉस और फिर से रिकर्सिव कॉल कर दीजिए एक्सपो डीसी को a, अब इसका पैरामीटर n-1 दीजिए, n-1. और इस एल्गोरिथम को अगर हम इंप्लीमेंट करें लाइक दिस वे, it will give the same result which this a power 27 has given. So that means if n is equal to 1, t of n is equal to 0, some constant. अगर n even है तो t of n by 2 plus 1, n by 2, और ये डिवाइडिंग फंक्शन है t of n by 2 and its complexity is log of n, फाइंड हमने की है. और अगर ऑड है तो t of n minus 1 which is equal to order of n. Means in one case it becomes a dividing function case, in another it becomes a decreasing one. So very simple, it's nothing critical about here, है ना. अब थर्ड वाला केस जो है वो है मल्टीप्लाइंग लार्ज इंटीजर्स. बहुत बड़े इंटीजर हमें दिए गए हैं, उनको आपस में हमने लड़ाना है, मल्टीप्लाई कराना है। इसको बोलते हैं कैरत्सुबास एल्गोरिथम। एक बहुत ही प्यारा बंदा है जिसने सोसाइटी के लिए ये काम किया है ना। तो what he said is that initially if we are hang the two numbers x 1 2 3 4 and y 5 6 7 8, and if we find x into y we will get this value. I have done it, but this is the traditional way of multiplication. How we do it? हम सबसे पहले we will take this 8 और इसको मल्टीप्लाई करेंगे 4 के साथ। कैरी जो आएगा 8 को मल्टीप्लाई करेंगे 3 के साथ, ऐड करके 8 को मल्टीप्लाई करेंगे 2 के साथ, ऐड करके 8 को 1 के साथ। मीन्स 8 को हमने 4 बार मल्टीप्लिकेशन कराना है। फिर दूसरा एलिमेंट लेंगे 7, 4 बार इसको भी कराना है। फिर 6 लेंगे, 4 बार उसको भी कराना है ना। ऐसे ही करते हैं ना, आप लोग ऐसे ही करते हो ना गुजरात में। हाँ, तो फिर 5वां लेंगे 5, इसको भी 4 बार इसके साथ। So which means I had to take it 4 plus 4 plus 4 plus 4. I had to perform n square multiplications. 16 here. So n is equal to 4, which means 4 into 4, 16 multiplication I had to perform in order to get this result. So Karatsuba gave a pseudocode of divide and conquer algorithm. He said that let's take this x is equal to 1 2 3 4 जो ये पहले था, let's take y is equal to 5 6 7 8 जो ये पहले था। Let's divide this y into two parts, a आधा b आधा। x वाला जो है इसको भी c आधा d आधा, इसको नाम देंगे a b, इसको नाम देंगे c d। मतलब अब मैंने बड़े नंबर को छोटे नंबरों में डिवाइड किया। अब स्टेप नंबर फर्स्ट आता है। अब यहाँ पे मैं जाता हूँ, स्टेप फर्स्ट ऑफ Karatsuba algorithm for multiplying large numbers. Find a cross c. This is a equal to 56. This is c equal to 12. So 56 into 12, which is equal to 6 7. Okay, 672. This is step number 1. Step number 2 is find b cross d. b is 78, d is 34. ठीक है, रिजल्ट ये आ गया। अब स्टेप नंबर 3 में क्या है? फाइंड a प्लस बी, उसको मल्टीप्लाई करो c प्लस डी के साथ। दिस इज a प्लस बी, 56 प्लस 78 वही मैंने यहाँ पे लिखा, उसको इंटू करो c प्लस डी के साथ, 12 प्लस 34 वही मैंने यहाँ पे लिखा, वो इसके बराबर आता है। चौथा स्टेप, जो ये 3 स्टेप है, स्टेप 3 उसको सब्ट्रैक्ट करो स्टेप 2 के साथ, उसको सब्ट्रैक्ट करो स्टेप 1 के साथ। 6164 minus 2652 minus 672, that's equal to this thing, है ना। स्टेप 3 मैंने यहाँ 4 स्टेप पे मैं पहुंच गया। अब 4 स्टेप पे पहुंचने के लिए एक तो मुझे यहाँ पे मल्टीप्लिकेशन करनी पड़ी, एक यहाँ पे करनी पड़ी, एक यहाँ पे करनी पड़ी। दैट्स 3 मल्टीप्लिकेशन टिल नाउ। हियर आई वाज नीडिंग 16 इन टोटल। यहाँ पे यहाँ तक मुझे 3 ही आएगी। नाउ स्टेप 5। स्टेप 5 कहता है कि जो स्टेप 1 है ना 672, उसको उठाओ, उसको यहाँ पे लिख दो 672 और उसके राइट साइड में 4 0 अपेंड करो। Why? We will discuss that. But for the time being, take 672, add 4 0 to its right. Okay. और दूसरा क्या है? The step 2, whatever the value you got it here, 2652, उसको यहाँ पे ऐड करो। है ना। और स्टेप 4 में जो वैल्यू आपने फाइंड किया 2840 यहाँ पे रखो, उसको 2 0 अपेंड करो, add 2 zeros to its right, then take addition of all those three, you will get the original value, that is equal to 7006652. Yes, we will get it, है ना। देखो मुझे पढ़ाना है, मुझे ये नहीं देखना है कि कितनों को समझ आता है, कितना मुझे पढ़ाना है, मुझे अपना काम तो करना है। और अब क्या करूं, इसके अलावा क्या कर सकते हैं, है ना। अब हम यहाँ पे जा रहे हैं, नाउ फोकस ऑन दिस पार्ट। I have divided x into 1, 2, 3, 4 into C and D, y which is equal to this thing A into B. So n is equal to 4 in this case, which का मतलब है कि total number of digits in a particular number is 4. 1 2 3 4 नंबर इसमें है, 4 इसमें है, तो वही n कितने कितने डिजिट का नंबर है, n is equal to 4. सो जो y है ना 5 6 7 8, y 5 6 7 8 जो था, इसको मैंने डिवाइड किया दो नंबर में, a और b। इसका मतलब है अब जो नया नंबर है वो ए बी है, वो y नहीं है, वो 5 6 7 8, वो y is equal to ab now. Okay, and this b is at units place and this a is at, okay, so if I write it y equal to I can multiply this a with 10 because it's a tens place to the power n by 2, okay, into ये मैं a को देता हूं प्लस, चूंकि ये यूनिट्स प्लेस पे है ये वाला नंबर b 10 पावर 1, वो 10 इसके बराबर ही होगा 10 पावर 0, that will be equal to b itself. So why I am doing it, that since my number is equal to n is equal to 4, so if I substitute 10 and in place of n I substitute 4 here, it will become 4 by 2, that will be equal to 2, so it will become 10 square, so that will be 100. That 100 into a, a is equal to what, 56, it will become 5600 plus this b is equal to 78, 5600 plus 78, that will become the original number. तो मैं इसको ऐसे लिख सकता हूँ y को, and similarly I can write x as equal to like this so as to get this number. इसका मतलब क्या है, फिर से 10 स्क्वायर 100 into c, that will be 1200 plus d, that will be 34, 1234, है ना। अब इस x और y को मुझे मल्टीप्लिकेशन करनी है, because that is the actual target. I had to find x cross y, means I had to multiply this thing with this thing, और इसी को फिर इसके साथ, फिर b को पहले इसके साथ और b को फिर इसके साथ. So if I carry on the multiplication, ये 10 पावर n by 2 into a, इसको 10 पावर n by 2 into c के साथ multiplication. So 10 power n by 2, 10 power n by 2 base are same, powers will be added, so it be 10 power 2 n by 2 into a और c को आपस में ac, हाँ, प्लस अब इस b को मैं करूंगा, b को करूंगा इसके साथ, नहीं इसी को करेंगे अब इस दूसरे वाले के साथ, है ना। 10 पावर n by 2 a into d, 10 पावर n by 2 a into d प्लस अब 10 पावर n by 2, अब b को हम लेंगे, इसको करेंगे इसके साथ, ये 10 पावर n by 2 b into c प्लस फाइनली बच गया b और d, हाँ। तो अब जब इसको मैं एक्सपेंड करूं, दिस विल बिकम 10 पावर n बिकॉज 2 and 2 विल गेट कैंसल, दिस विल बी ac प्लस 10 पावर n by 2, 10 पावर n by 2 दो बार है, आई विल टेक इट कॉमन, internally I will be having AD plus BC and finally I will be left with BD. So this becomes actually my general formula of Karatsuba's algorithm. This is the actual formula. So not taking n is equal to 4, even if n is equal to 100, n is equal to 400, whatever the number is, just put that n value here, whatever the result we get, that will be the solution of our multiplication finally. So that means here we perform one multiplication, this is another. If we take this 10 power also into consideration, this is one multiplication, this is another 2, 3, 4, 5, and 6. With just 6 multiplications, we get the same result which we got here using 16 multiplications. So if I substitute the value n is equal to 4 here, this will become 10 power 4 into, in place of a, 56, c, 12, 10 power n, 4 by 2 square. Finally, it will be equal to what I actually got. And if you see here, I am multiplying this 56 into 12 by 10 power 4, which means 1, and on the right side there will be 4 zeros. And that's why I added those 4 zeros here. This 672 is the multiplication of 5, 6 into 1, 2. And here I added 2 zeros, and that 2 zero actually comes from this 10 square. So that was actually simple way to remember. The actual formula is this thing. And if you want to have a rata type of algorithm, that I have also prepared. So we need order of n square in the traditional way of multiplication. So what we do, we divide n digit number into two numbers of size n by 2, n by 2. And we store that value from n minus 1 to m into another variable w, and from m minus 1 to 0, means from left to half and half minus 1 to 0, we store it another variable, that's x. Similarly, for another number, we store it in y from n minus 1 to m and from m minus 1 to 0 in z. So we divide it into two actual partitions, half partition in w, half in x, and the second number whose half in y, half in z. Then we write it like this, x sort of array, w here, w, x here, y here, z here, जिसको रट्टा लगाना है. उसके बाद ग्रीन एरो पे जाइए, ग्रीन पे इस w को मैं z के साथ मल्टीप्लिकेशन करता हूँ, w इंटू z, दिस इज हियर, एड एक्स z, ग्रीन वाला हियर. उसके बाद ब्लू, w y एंड एक्स वाई, एक्स वाई ऐसे लिखता हूं कि ये इसके ऊपर आना चाहिए, ये दो ओवरलैप होने चाहिए, दे विल बी इन द सेम कॉलम. Then I just take this wy as such, take their sum, take this as such, this will be the final product in a rata manner. And this is what I have written in this example also. It is same thing, only we are taking the numbers a and b, which is again equal to 4. So half will be equal to 2. We will divide it into 4. W, we will start 12 here, 34 here, 12 here, 34 here. We will directly put the values inside that equation and we get the result here. Okay. So stopping it here. भाई किसी